Welcome back, grade 9s. This is going to be part 2 of our polynomials unit. So in our last video, we did the pre-unit review. We learned about the commutative rule and reviewed some exponent laws. Today, we are going to look at the grade 9 polynomials introduction. Below, you're going to see some polynomials. I also have examples of what a polynomial is not. I've given those examples in red and the polynomials in blue. What I want you to do is pause the screen in a bit and take a look at what makes a polynomial and what does not make a polynomial. So I want you to take a look and just compare the different examples, the blue and the red, and see what differences you can spot out. What is a polynomial? Well, there's a polynomial. What we're going to do is we're going to dissect the word a little bit. Polynomial. Poly actually means many, and nomial means terms. So let's put those words together. Polynomial. Many terms. So we're going to go through some classic polynomial definitions. Terms. As we talked about, a polynomial is many terms. So a term is different values separated by addition or subtraction. This polynomial has 3 terms. 1, 2, 3. Variables are something you're going to need to use as well with a polynomial. Now, a variable is an unknown value represented with a letter. They are located here using X. Now I could have used Y, could have used Z, a smiley face, a sad face, but X is our common variable. So I chose X. Coefficients, a value multiplying with a variable. It coincides with it. So I want you to take a look at these 2 variables, X here and X here, and the number that coexists, that is cooperating, that coincides with that variable is our coefficient. So our 3 and the 2 are a coefficient. A common mistake in grade 9 is they'll call this 1 a coefficient. This 1 is not a coefficient. It is known as the constant, a value isolated from variables. It is constantly the same. So when I identify what X is as a value, it will have no influence on my 1. That's why 1 is called a constant. So here I found some images of examples of what make a polynomial and what does not make a polynomial. Over on the left side here, this is step by step. So division by a variable. So 5 divided by X, that is not a polynomial. X is underneath. Negative exponents. Anything with a negative exponent is the same thing as having a division by an exponent or variable. So an example here is x to the power of negative 2. It's the same thing as writing 1 over x squared. These are equivalent. So going back to our sheet here, we can say that if I have x to the power of negative 2, it's the same thing as 1 over x, which is division. We cannot have division by a variable. Next, decimal exponents. So over here we have x to the power of 3.2. That is going to be a non-polynomial. An infinite number of terms. So a polynomial will have a finite number of terms. Here are some more classic definitions. Degree. The degree of a polynomial is shown by the highest exponent. Now this is not always the case. This is just an example right now for introducing polynomials, because we're going to take a look at basic polynomials with 1 variable. So 3x squared plus 2x plus 1. The highest exponent in this example is what? Well, we have a term here with x squared, power of 2. We have a term here with x. Now keep in mind there's a hidden 1 for that exponent of x, right? X to the power of 1. In fact, here you can think of it as x to the power of 0. Remember that x to the power of 0 is 1. So that's why we have that multiplying there. So there's an x in every term. The highest degree in this case is 2. Over here, I have 2 terms. 2x to the power of 3 minus 2x to the power of 5. The highest degree for this polynomial is 5. So it's a degree 5 polynomial. Standard form. So ordering the terms from highest degree to lowest degree. So here we have 3 terms. I have 2x to the power of 3 plus 5 minus 10 times x here. We want to reorganize this expression so that it's going from highest degree to lowest degree term. Notice that I switched my 10x and my 5. The negative sticks with the 10. It is a negative 10x. So it's pulled with that 10. We have now ordered it from highest degree to lowest degree. Remember, there is a x here to the exponent of 0, right? Because x to the power of 0 is 1, and then 1 times 5 is going to give us 5. Here's another expression, highest degree to lowest degree. Let's take a look at the exponents. Exponents 4, 7, and 5. So we're going to reorder it to go 7, 5, and 4. Keep in mind the negatives are going to be attached to those coefficients because those are negative values. And our last one here, 19m plus 5m cubed minus 2m squared. We are going to order this in the standard form from highest degree down to lowest degree. Continuing our classic definitions. The leading coefficient. The coefficient leading the polynomial in standard form. Here I have 2x cubed minus 10x plus 5. So I've already organized this into standard form for you. In fact, it's an example from the last slide. The leading coefficient is the coefficient leading our polynomial expression in standard form. So standard form, there's a 2 there leading it. Therefore, my leading coefficient is 2. Let's carry on with our examples from the other slide. Excellent. So I'm going to teach you 3 terms here. 3 basic terms for polynomial. So we have monomial, binomial, and trinomial. Monomial, I want you to bold the mono there. And binomial, I want you to bold the bi. And trinomial, I want you to bold the tri. There's a reason we're doing this. Mono means 1, bi means 2, and tri means 3. Mono is like mono a mono, one-on-one. When you think of bi, I want you to think of a bicycle, 2 wheels, and tri, you can think of a tricycle, 3 wheels. So monomial means 1 term, binomial means 2 terms, and trinomial is going to mean 3 terms. Here are some examples of a monomial. And now I'll show you some examples of a binomial. Now notice they are separated by an additive operation, so adding or subtracting. And over here, there's no separation occurring because they are single terms. And here's our trinomial. Just some examples for you. Notice that you can have multiple variables in a polynomial expression. And we'll talk about what impact that has in later videos. And there you have it. Our intro to polynomials. We went through definitions, what makes a polynomial, what does not make a polynomial. Next video, we're going to introduce algebra tiles, which will be a tool that you can use for adding, subtracting, multiplying, dividing polynomials.